Here we go. 5.6b. This is the last video lecture I'm going to ever make until I make my next one. Kind of sad moment for me. But let's just brighten it up by talking about complex number solutions. And really what this lesson is all about is if I were to give you a quadratic like I did down here and a solution that is complex, how could you figure out if this was actually a solution? Maybe I'm tricking you. What could you do to make sure that it's a solution? Because maybe you just don't ever believe me. And so that's what this lesson is all about, not believing Mr. Benson and figuring out, is he trying to trick me or not? And I got two methods for you for doing this. The first one is method 1, enter a solution into the equation. Now there's only specific times you want to use this method, guys. And it's when you're dealing with the imaginary number, okay? For example, an imaginary number would be 4i. That's an imaginary number. When you're dealing with those are really easy to take and plug into these equations right here and solve. But when you're dealing with complex numbers, let's say a complex like 2 plus 3i, if you're going to plug that into the x's here, that gets really complicated fast. And so there's a different method for that. So when you're dealing with imaginary numbers, you want to just plug them in. But when you're dealing with complex numbers, then what you want to do is you want to solve the quadratic using the quadratic formula. Okay? So I'm going to show you both these methods. We're going to start with the first one. Method 1 is entering the solution to the equation. So let's say Mr. Benson one day said, hey, I got this quadratic here, guys, and the solution is 2i. And you're like, no way, Mr. Benson, it is not 2i. I'm going to prove it to you that it's not. Or maybe you believe me and you're just like, nah. Let's see if he's telling the truth. So let's go through some steps to make sure. Step 1 is enter solution in for every x. So let's do that. We're going to take this 2i, put it in for every x over here and here. So I'm going to put it there and there. So I got 2i squared plus 2 times 2i. That's for this part, plus 5. Okay, so I just entered it in. Next step, we got to simplify this. Well, it's doable. So I got 2i squared, that's 4i squared, if I simplify that out, because I distribute the 2 to the I and the 2. And then I got 2 times 2i, which is 4i plus 5. Forgot to put my 0 at the end, sorry. I remember my I squared is -1, so I got -4 plus 4i plus 5 is equal to 0. And then I'll bring these two together, so I got 4i plus 1 is equal to 0. So I simplified as much as I can. So is it a solution? Well, the only way it's a solution is if it makes sense. And is 4i plus 1 equals 0? No, that doesn't make any sense. That's false. Therefore, right here, this is a therefore. Right there, those 3 dots. Therefore, 2i is not a solution to this quadratic formula or equation right there. So that is the method 1 for just entering them in. The only time you want to use this method is when you're dealing with imaginary numbers, not complex ones. Those are a pain in the butt to plug in here. Only imaginary numbers like 4i or 5i or 12i. But once you have a 2 plus 3i, that's stop. Don't make your life that hard. That's for the next one, okay? And I'll show you that in a moment. Beep.